Okay, in today's video, we are dividing with exponents. First, we are asked to expand the following. This will help us see how we can develop the quotient rule here. So if we expand x to the sixth power, think of a rubber band. What does that mean? We are expanding this, so x to the sixth means x times x times x times x times x times x. So that means we are multiplying the x value by itself 6 times, and that's what we see. Then we have x to the second power. So it's x times x. Now, we were always taught that when you have something on the top and something on the bottom, when divided, okay, because you remember this is division, x divided by x is 1, so we can cancel these out, and what we're left with is 4 x's, so we have x to the fourth. Now, instead of doing all of this, say if these were very large numbers instead of 6 and 2, you wouldn't want to write out all those x's and all those y's or w's or whatever variable you're dealing with. But how can we go from problem to answer? If you notice that 6 minus 2 gives us 4. So for our rule for dividing with exponents, which is our quotient rule, whenever we have a base, and the bases are the same, raised to an exponent, and we're dividing x to the a power divided by x to the b power, we can simply subtract the exponents, and that would give us our quotient rule. So when dividing monomials, use the quotient rule. But couple things that you have to remember when the bases are the same, the bases must be the same in order to subtract the exponents. If the bases are not the same, then we could not perform the quotient rule. So if we had x to the sixth power divided by y to the second power, our answer would just be x to the sixth power divided by y to the second power. You would not be able to subtract the exponents because the bases are not the same. However, if coefficients are present, they still follow the division of the problem. Just like when we were multiplying with exponents, you multiply the coefficients. Well, when you're dividing, you will divide the coefficients. And we'll see that in a couple of minutes. Now, for our model problem here, number 1, we have x to the 8th power divided by x to the 3rd power. Bases are the same. They're both x, so x will stay the same. And we will just subtract the exponents because by the quotient rule, we can subtract them. So 8 minus 3 gives us x to the 5th power. And that's our final answer. Whatever x would be, we would multiply it by itself 5 times to get our final answer. For number 2, now we have multiple terms. Whenever we have multiple terms, you would want to kind of split them up. So we would deal with the coefficients separately, the x's separately, and the y's separately. So you would have 24 divided by 8. Then you would have the x's. So it would be x to the 11 minus 3. And the y's would be y to the 12 minus 9. We would then give our final answer. The coefficients get divided. 24 divided by 8 is 3. And 11 minus 3 is 8. So x to the 8th power. And 12 minus 9 is 3. So we have 3x to the 8th, y to the 3rd. And that's what that would simplify to. So if you just separate the values, each term inside, then you can just use the quotient rule, divide your coefficients, and get your final answer easily. So why don't you take a moment, pause the video, and try your check for understanding, and then come back to see if you got the correct answer. Okay, so number 1, we have x to the 16th divided by x to the 7th. So x to the 16th, the bases are the same, so we can do x to the 16 minus 7, and we get x to the 9th power. And finally, number 2, we can split these up. We get 54 divided by 9, which is 6. X to the 5th divided by x to the 3rd, which is 5 minus 3, which is x to the 2nd. And y to the 9th divided by y to the 5th, which is y to the 4th after subtraction. If these happen to be a 0 exponent or a negative exponent, you would know that you would not be completely finished. You would have to do one last step to get rid of that negative exponent or rid of that 0 exponent, and then complete your final answer. So this concludes dividing with exponents.